Liquid guy. Liquid AI is a startup that is basically rewriting some of the bottom of the stack. And if you think about the neural networks that we're using, in a way, they are a surprisingly crude idea. They're not like biological neurons at all. And the biological neuron is a small animal that tries to survive. It's quite complicated. It's really a single-cell animal that is able to learn message passing and then perform computational tasks in the service of a larger group of cells. But the neuron in the neural network is a real number that is a result of summing up other real numbers and multiplying them with weights, right? So it's just sums and multiplications that we arrange into a series of steps. And then when we make a model, we predefine the shape of this function. We, for instance, say we have 100 layers, which means we have 100 steps of adding up. And each of those layers has maybe 1 million weights, which means we make 1 million multiplications of individual values on the previous layer and propagate them to the next. And then we adjust the weights in the hope that our function fits into this thing. So it's not an optimal use of space, because the space can be an arbitrary function. And in context of deep learning, we look at the differentiable function. So we express the function in such a way that it's somewhat continuous. And this allows us to shift the function around, and that makes the whole thing learnable. We basically hope that in many domains we can define it so that small nudges in the function make it slightly better at, for instance, telling dogs from cats, even though this is a discontinuous problem. It's amazing that this works at all when you think about it. But it's not the best way in which you could represent such a differentiable function. Maybe you want to represent it directly as a system of differential equations and then shift the parameters around with a second level learning system. And so this is things that Liquid AI is exploring. And it's by now it works. Initial work that we did with liquid neural networks was flying drones around, so in some sense cybernetic control tasks, and showing that this works pretty well. And Ramin Hassani in his PhD has shown that these liquid neural networks are more expressive than normal neural networks. Basically means that per memory cell, per compute step, you're expressing more of the features that you actually care about in your function. And that translates into having models that are cheaper to train and more efficient to run, and they need less memory. And the thing that we're doing now is that we are training this thing to build LLMs. And now we basically have built internally some mid-sized models that we can show actually quite efficient and run at SOTA. So these methods basically can supplement some of the existing machine learning methods with slightly more intelligent algorithms. But there is a lot of potential that we are not using yet. For instance, because these liquid neural networks have a continuous depth and a continuous resolution, they basically flow into the shape of the function that you need. And this means you could, in principle, build systems that continuously learn rather than being just trained on one batch of images and then you retrain them at a later point from scratch. Instead, you could continuously train them. But there are, of course, difficulties that come with this when you need to edit your knowledge in such a way that the thing doesn't break down. And so there's a lot of research that we still need to do, but this makes it very exciting because it feels that we basically open up a fresh avenue of research.